All right, here's warm-up 6.7. We're going to be solving some equations, some exponential equations. We're going to use logs here. Okay, so I'm going to need a calculator at some point. All right, let's solve with logs. We're going to round to the nearest hundredth. So I'm going to need to put this in log form in order to solve. Only way that I can isolate the x there is with log form. So my base is 4. The long number is going to be the argument or the contents of the log. And then the x gets isolated, okay? And then when I'm putting this in my calculator, I'm going to need to use base 10 on my particular calculator. So here's what it's going to look like in base 10 with the change of base formula. Okay, so I'm going to take the log of the large number, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to close the parentheses, and I'm going to divide that by the log of 4. And then I've got 13.44. Okay, and nice thing about these is you can always test it out. This means 4 raised to the 13.44 is going to be roughly the long number. Now I've rounded that a little bit, so it's not going to be exact, but you can see that's pretty close to 1, 2, 3, 4, 5, and then it gets off a little bit. But if I use that longer decimal, 4 to the 13.43971547, it's going to be closer. This number is still rounded a bit, but this is approximate, okay? All right, so next problem. Log of 13. 13 is my base. Then the long number is the argument again. The x gets isolated. So in my calculator, I'm going to do log of the large number over the log of 13. I'm not going to rewrite that on the paper, but I'll put it in here. Close the parentheses and divide by log of 13. And then I've got 8.07 roughly. Okay. All right, next up, I've got this equation I'm going to solve for x. So when I have multiple logs, generally I want to combine them, and I can combine these two logs here. They have the same base. There's no coefficients in front of the log. So when you're adding logs with the same base, you multiply the contents together when you combine it. So this is going to be log base 3 of 3x equals log base 3 of 45. Okay? Now I could still combine these two logs by subtracting this log from both sides or something like that. You could definitely do that. But when I have just two logs that are equal to each other with the same base, well, that means that the contents have to be equal. The only way to get this to balance out is if 3x and 45 are equal to each other. So I'm just going to say, okay, 3x equals 45 then, and I'll solve by dividing by 3 then, and that's going to save me a lot of time. And x equals 15. Okay. All right, next problem. These are logs. Remember, ln means that's a log with a base n. So I can combine these because they're both base e, but first I have to move the coefficients into the exponent slots using the power rule. So this is going to be the same as natural log of x squared minus natural log of 2 to the third. Okay, so now I can combine these. And 2 to the third is 8, right? So when I combine, these logs have the same base. I'm subtracting. When I'm subtracting, I'm going to divide. So this is going to be x squared over 2 to the third, or 8. Like that, okay? Now I need to get the x isolated, so I got to get the x out of that log. So I'm going to have to convert this into exponential form. So you got to remember that log base e is what natural log means. Then when I convert this, it's going to be e to the third. My base is e. The exponent's isolated. So e to the third equals the contents, which is the fraction. Okay. So now I'm isolating x. I'm going to multiply both sides by 8. And then the very last step is to take the square root. Okay. Now, typically, if I was just solving for x here, when I take the square root of both sides of an equation, I'm going to do the positive and negative square root. But the thing is, with this one, you can't have negative contents to a log. So the negative one is actually going to be extraneous here. Okay. So I'm actually just going to use the positive root of 8e to the third. Okay, and you could leave it like that if you wanted an exact answer, but I'm going to use my calculator here. So let's see, e to the third, there it is. I'm going to multiply that by 8. Then I'm going to take the square root of that number. And the more of it you use, the better. You could use the last answer button on your calculator too. And then I've got about 12.68. Okay, so if you did the negative 12 point, if you did the plus minus, negative 12.68 would make the contents of that log negative, so it would be extraneous. So that's my only solution here, okay? All right, next up. So I'm going to use the power rule again to move these coefficients so that I can combine these logs. So this is going to be log base 6 of 4 squared minus log base 6 of 8 to the 1/3. Okay, and 4 squared is 16. You could combine them right now, but I'm going to simplify these first. And then 8 to the 1/3, that's the same as the cube root of 8. So you could type it in a calculator, but the cube root of 8 is 2. Okay, so now when I combine these, since I'm subtracting, that means I divide the contents. Okay, and 16/2 is 8, so that means I've got log base 6 of 8 equals log base 6 of x. You could still combine these two by moving them both to the same side of the equation, but hey, I've got two logs with the same base that are equal to each other. That means their contents must be equal to each other. That means x is going to equal 8. Okay, last problem. So let's see, use logs to determine how long it would take for $100 to triple if compounded monthly. So compounding monthly, that means we're going to put the 12% into the account 4 times per year. No, that would be quarterly, just kidding. 12 times per year, 12 months in a year. Sorry. Okay, so that means our n is 12. All right, so we have to choose the right formula. We need the formula that has the n's in it. So it's going to look like this. Okay, A is the beginning amount, that's 100. And then Y is going to be the final amount. Well, if this is tripling, that means that $100 will become $300. Okay, my rate is going to be 12%, but remember that rate has to be written as a decimal. So I don't want to put in a 12, I want to put in 0.12, 0.12. Okay, and then n is 12, and there's another n up there, and the only thing we don't know is how long this is going to take. So the t is what we're looking for. Okay, so I'm going to start to try to isolate the t. So you can start by dividing both sides by 100. So this would actually take the same amount of time as it would for $1,000 to triple. It's just I'd have 1,000 and 3,000, but when you divide both sides, either way, any amount of money, it's going to be 3. And then I'm going to simplify this part while I'm at it. So I'm going to start with the decimal, which 0.12 divided by 12 is 0.01, right? Add 1 to that, and I've got 1.01 to the 12t, okay? And at this point, I can't isolate the t any further with my old algebra techniques. I need to put this in log form. So my base is going to be 1.01. The 12t, that's the exponent, that gets isolated, and then the 3 goes right here, okay? So I'm going to sort this part out in my calculator using change of base. That would be log of 3. Close the parentheses, divided by log of 1.01. Okay. So now I've got about 110.41 is equal to 12t. Okay, and then the last step would be divide by 12. Okay, and I'm going to still use that longer decimal I have in my calculator so I can divide that by 12 so I can get a more accurate answer. So this is going to be nearest hundredth of a year. It looks like it's going to be about 9.20. to put in the units there. It's going to take that many years. Okay. All right, that's the end of the warm-up, and I'll see you next time.